In Module 101, we learned about the const keyword, and we used it to declare constant variables. Now in this module, we'll be using const quite often. We'll be using it in functions, in function parameters, and with pointers, as we'll see in this video. Now const is a qualifier, and a qualifier keyword applied to a type results in a qualified type. So type int, for example, by itself is unqualified, but const int is qualified as a constant integer or an integer constant. It specifies read-only variables or functions, but on a basic level it prevents modification. So if you specify something as const and you try and change it later on in your program, you'll get a compiler error. And as we'll see later with functions, if you declare the function itself to be const, then that function is not supposed to change the members of that object. So in a struct or a class, for example, but again, we'll discuss that later. Now there are other qualifiers such as volatile, and I might discuss those when we use them, so in a future lecture. For right now, we want to focus on the const qualifier. A tip for you on how to read pointer declarations, and this is going to become more important in upcoming subsections where things will get a bit more complex because we'll add the const qualifier in there as well. So reading it and understanding what's going on from the declaration is important. Otherwise, once again, it can be kind of confusing and debugging can be difficult if you don't understand what's going on. So what you want to do is you want to read the declaration from right to left. Here, for example, is a simple declaration as you are familiar with already. Demo pointer is a pointer to an integer. Of course, we also have it initialized to the address of x in this case, but the point here is demo pointer, that's the identifier. You have the asterisk and then an integer if you read it from right to left. So demo pointer is a pointer to an integer. Alright, so in this table we have a few pointer qualifications. In the first row we have a pointer to a constant. Again, reading from right to left, we have demo ptr, which is a pointer to an integer constant. So the pointer in this case can be modified to point elsewhere, but the data pointed to cannot be modified by dereferencing the demo pointer because of the const qualifier. That's not to say the variable pointed to is a constant. This simply has to do with the pointer declaration itself. So the pointer itself, if you dereference that pointer, you cannot go and modify or write to that location in memory. In the second row, we have constant pointers. So again, reading from right to left, demo pointer is a constant pointer to an integer. So the pointer cannot be modified to point elsewhere, but the data pointed to can be modified by dereferencing demo pointer. Then in the final row, we have constant pointers to constants. Demo ptr is a constant pointer to an integer constant. The pointer cannot be modified to point elsewhere, and the data pointed to cannot be modified by dereferencing demo pointer. Just a quick summary for you here. You can either screen grab this or make your own summary in OneNote or something like that. But the goal here is to understand that const means that that particular thing cannot be modified. And then also, once again, we read these declarations from right to left. I'll declare two variables. Then I'll go and declare a pointer to a constant integer. So we want to point to a constant integer. And I'll use the list notation for the initialization just to keep it consistent. I'll set that to point to the variable x. So we can change the pointer to point somewhere else. But if we try and dereference that, you will see we get an error. Expression must be a modifiable L value. Let's just go and build and run this, and you'll see we get an error. You cannot assign to a variable that is const. So even though x and y are not constant variables, we cannot go and do this because the pointer is a pointer to an integer constant. If I take that out, this works fine. Right, we're not actually doing anything with this demo, but you can see this works fine. But with this we get an error because we are dereferencing ptr and we are trying to assign 15 to it, but it is a constant integer or an integer constant, right? Next we'll do a constant pointer. Got that out. So you might think to place it to the left of that asterisk, but remember we read from right to left. So pointer is a constant pointer to an integer. Now we'll get the squigglies. because we are trying to change what that pointer points to. Of course, if we build and run, you'll get an error. Cannot assign to a variable that is const. Now, if the order is a bit weird, that's because I'm doing it in the order that I'm explaining it, so from right to left. PTR is a constant pointer, right? And here we are trying to change it, so we'll get an error. And it's a constant pointer to an integer, so it's fine if we dereference that and assign a different value to that. It's just that we cannot go and change the pointer itself to point to something else. Finally, we have a constant pointer to a constant. So PTR is a constant pointer to an integer constant. So we cannot change the pointer. We cannot assign another address to that pointer because the pointer is const. And similarly, we cannot dereference the pointer and assign a different value to it. You can see I do the dereferencing and I assign 15 to that. So I'm trying to change the value stored in that address. So this will also give me an error because it is an integer constant, even though once again the variables themselves, int x and y, those are not constants. So it simply has to do with the pointer declaration. We can dereference the pointer to get the value stored at the memory address where it is pointing, so we can read from that memory location. We just cannot write to it. You can see this works fine. So again, just note the difference. It's similar to a constant variable in the sense that we can use it or read from it, we just cannot modify it. I have one more important demo for you here. This relates to constant variables. So I have a constant integer called demo constant, which I set to 12. And then I just have int y once more. And this works fine. So I declare a pointer and I set that to the address of y. Then this will work fine. Here I change the value stored in that location. I set that to 12 and I just print that out. As soon as I change this, you can see the problem that arises with this, because with a pointer we can indirectly change the value stored at some memory address, right? But here we have specified this to be a constant integer. So in other words, we do not want this demo constant to be modifiable. And so here we'll get an error with this. If I build and run that, get an error such as conversion loses qualifiers, cannot convert from const int to int. And that's because this pointer does not point to a constant integer. So I change that and I get rid of that error. But now we have this problem because we are trying to change that still. We can just remove that and this will work fine now. So once more, we can now read from that address indirectly using the pointer. We simply cannot write to it. So in other words, it is now read only. I'll just build and run this and we'll get that output now. Demo constant is initialized to 12. Right, so that is a quick introduction to pointer qualifications, basically how to read pointer declarations, a recap on the const keyword, which basically allows us to specify what is modifiable in our code. Alright, so I hope you find this useful and I'll see you in the next video.